now that we have seen what variance measures, let's look at some of its most useful properties, right? So the first property is that the variance of a times x plus b is equal to a squared variance of x for constants. And so what this means is, first, that adding a constant, like adding this plus b part, does not change the variance. So for example, if everyone gets $5 extra, no matter what happens, then all the outcomes shift by 5, but the spread does not change. And so the random variable is centered at a different place, but the distance from the mean are the same, right? So it'll change the expectation, but it's not going to change the variance. However, when you multiply by a factor of a, that comes with the square. And so if you double all the outcomes, the distance from the mean doubles. But remember, the variance was the squared distance, so then it goes like 4 times. And so that's why you get a factor of a squared and not a. Now, the second important property is about sums. So if x and y are independent random variables, then the sum of the variance, so the variance of the sum is the sum of the variance. And so remember that for expectations, the sum of the expectations, the expectation of the sum was always the sum of the expectation. So this was true always, but this one is true only if they are independent random variables, right? So if your random variables are independent. So it's not true that this is true for every random variables. It's only true when they are independent. This one is true always, but this one only for independent. Now, in general, the variance of the sum is going to be the sum of the variances, but it's going to have this other factor here. And so this factor is called the covariance, and it's defined like this. And so what is the covariance, or what is it measuring? So the covariance term, it essentially measures whether x and y tend to move together. So if positive values of x tend to happen with positive values of y, the covariance will be positive. And if positive values of x tend to happen with negative values of y, then the covariance can be negative. And finally, the variance is always a non-negative number. And this makes sense because, again, remember the definition that the variance was equal to the expectation of x to the mean squared. And so since this is the square of a number, this is going to be positive, and so the expectation of this will be positive, right? And the variance is going to be 0 only when you have no uncertainty here, so when x is a constant, so when there is no uncertainty. So again, the variance gives us a precise way of measuring spread. Small variance means the outcomes are close to the mean. Large variance means the outcomes are more spread out. And a zero variance means that there is no randomness in the value of x.